Hi there, my name is Simon Moffat, founder and research analyst at the Cyberhut. And in this video, I'm getting the chance to sit down with Ev from Teleport to discuss the brand new Agentic AI framework that Teleport have been working on and a few more other topics as well. So Ev, thank you for joining me.
Thanks for having me. It's good to be back. I really enjoy coming here.
Not at all. It's good to be speaking with founders and leaders all around the sort of global identity security world. And I guess the topic, which is the top of everybody's mind, really, both end users and sort of technology stakeholders, is AI, and I guess specifically agentic AI. And this is clearly the AI evolution and sort of innovation pipeline, if you will, is on this hugely fast and rapid adoption curve. And it seems to be touching every single sector, public sector, private sector, every single verticals. And I guess the productivity benefits of AI and agentic AI, you cannot argue with some of the benefits it brings, but it clearly seems there's a gap, a security and identity gap, potentially limiting some of those areas. So I guess maybe bring you in what this agentic stuff. It seems to be here to stay. I guess it's the next big industrial revolution. Is that fair?
Yes, I don't think anyone is actually arguing for AI going away. Or maybe you know some people, I don't.
I don't. I think it's here to stay. And one thing I want to instantly bring up though is the benefits are huge, and I think the benefits are they are going to cut across all of the sort of services we leverage online, public sector, private sector, the way we interact with everybody. And that adoption curve over the last 12, 18 months has been pretty stratospheric. Productivity is measurable. We have this concern around things like shadow AI and the sort of consumption of maybe SaaS systems as well. So the adoption and the time adoption curve is huge. But I think what the real issue I think which we all want to discuss ultimately is this gap around security. Our traditional identity and cybersecurity controls are ultimately not keeping pace or haven't been keeping pace with a whole host of issues. I guess more recently NHI and workloads and infrastructure, but now suddenly we have the agentic stuff to deal with as well. So how can we deal with this? Is that first of all, is that fair?
Absolutely. We actually had this problem slowly brewing even before AI even showed up, and plenty of people noticed it. And we were talking about Google security white papers before we even started recording today. So, like, there is plenty of literature that actually describes this exact same phenomena. Again, it existed even before AI. But the basic idea is that probability of an organization getting breached, it's not zero. It's never zero. Smart people will never say, like, we're like a giant bank and we're 100% secure. No, it's never 100. So the probability is small. But the problem is that complexity of computing, because it constantly increases, it pushes that probability of getting hacked up, and that probability is growing faster than business itself. So like the different interpretation on the graph that you're showing is that the slower growing line, that's your business, that's you growing, but the complexity of your compute is actually going up much faster. So it's more like exponential curve, and complexity of your computing is directly related to probability of you getting hacked. And what's happening now when AI enters the picture, that complexity is exploding. So you're starting to see this divergence much sooner. And smaller organizations are now starting to notice this. So yeah, it's very much relevant. So like this used to be a problem that only hyperscalers had, like the companies like Apple and Google, because they're massive and the complexity they're dealing with is really high. But now this same problem is facing organizations who are much smaller because of AI.
Yeah, I absolutely agree on this one. I think there's my analogy I've been using recently is AI is a bit like a hose pipe, if you like, and you have your roof on your house, which may have some leaks in that roof, which you may be comfortable dealing with the rain is just dripping down occasionally. But AI is like this super powered hose pipe, and it will find the vulnerabilities in your ecosystem. It will amplify the complexity like you analysed there. And I think the other thing I'll just add in finally there is it's a cascading problem, because I
Hmm.
think many organisations haven't solved the human identity world.
Yes.
Excess permissions, strong auth, all of that sort of stuff. And then you add in things like workloads, services, and all of the sort of volume of that sort of workload infrastructure world. But now you have to add in this very
Yeah.
strange beast of agentic, which is the sort of the worst of both worlds, isn't it?
Do, do you want me to dive a little bit deeper to illustrate with a very easy to understand example? How is
Absolutely.
it actually happening? So I think, well, your audience, obviously, the people who understand cyber, so obviously technical audience. So, and everyone by now understands the importance of static credentials. That we have this credential sprawl. We have SSH keys, we have API keys, we have browser cookies, session token. They're basically credentials are everywhere. And and for years and years, the industry has been kind of learning and developing opinions on how that what's the best way to manage these credentials. Oh, we need to rotate passwords, or we need to like encrypt things. We need to put things into a vault. So like all these efforts that have been made to contain those credentials to prevent credentials from leaking. So now let's examine what complexity does to this problem. So if I ask you, what's the probability of you getting hacked during this podcast, during this hour? You will say, like, well, the probability is not zero, but it's very, very low. This is why I'm here, kind of comfortable talking to you. But then, okay, let's see what will make that probability go up or down over time. So let's just say if in your organization you hire twice as many people next year, will the probability of a credential leaking double? Most people, of course, say, yeah, sure, it's a simple math. So probability of credential leaking is essentially, it's related to probability of a human making a mistake and they become victim of a phishing attack of some form, and the credential leak. So the more humans you have in your organization, then the probability of credential leaking go up. Okay. Now, but what happens if your infrastructure grows? So you go from 1,000 servers to a million servers, or you go from just AWS and you go multi-cloud. Now you have like Azure enters the chat, or you acquire a company that has kind of bare metal dedicated data centers that they're operating. So now you have more gear everywhere. So probably means more credentials. So the probability of one of them leaking probably goes up as well. Yes, most people will say yes. But the most interesting thing is all the software that you're deploying into your environments. Like you didn't have Kubernetes before. Now you're moving to Kubernetes. You have this additional complex technology that comes with its own credentials. And the list goes on and on. You might start like you deploy GitLab, you deploy Grafana, you keep adding to this complexity. That also breeds additional credentials. But here's where that exponential curve comes from that we're looking at on your screen. All of these three things happening at the same time. Most successful organizations are hiring more people, are getting more hardware, are introducing more complexity. So they compound. So the probability of a credential leak it's going to grow faster than your revenue, which means that at some point you're going to hit a wall. And now, if you introduce AI into the picture, that explosion happens much sooner. So I recently spoke to a technology executive from a fairly large institution where he shared some numbers with me that like the certain work that they used to do like that would require for example like 2,000 human identities in their computing environments. Now they're being building an AI system that's going to do the same thing, but it's going to be 250,000 AI agents. That's a factor of like two orders of magnitude jump. So that is exactly what, and this is just credentials we're talking about, because you have similar explosion happening with role-based access control. Like most organizations have more roles than they have employees, and now they're bringing AI agents, and now they're going to start looking at millions of different roles in the organization, no one even understanding what they do. So that's that explosion. That's the curve that we're looking at, and that's what the industry now needs to solve.
I think
Essentially, I'm saying
that
that before deploying AI into production, your infrastructure needs to become AI ready. And that's why we published the framework.
that's a really fascinating thing, isn't it? You sort of, I think many organizations or many designers sort of think of AI as a separate entity, like a little bubble that you just wrap and it's okay. But it's sitting on top of and interacts with a whole host of other components. You mentioned the hardware and software angles, the supply chain, many of which you're probably not under control with. But the one I want to sort of amplify a little bit before we sort of dive into the framework is that relationships with people. I think that is another one which is often being forgotten around. It has to somehow link back to a carbon life form or a person of some sort, so that you have that accountability and traceability, and you have that sort of end-to-end verification, visibility. And other. What's your view there before we sort of dive into the framework?
First of all, congratulations on a pretty awesome joke. um, by the way, this is the root. It's one of the biggest questions that cybersecurity industry, or like all of us cybersecurity professionals, we need to answer. What is AI, or who is AI? And I see 4 different camps or kind of schools of thought. So there is basically kind of difference of opinion that exists now in the industry. And obviously there are incentives behind it. So for example, should we treat AI as humans, or should we treat AI as machines, applications, right? So there are 4 answers. Answer number 1 is that, like a traditional cybersecurity vendor that used to manage human identity historically, we all know who these guys are. Like, we all use their products. We all love their products. They would say, yeah, you should use our products to issue identities to AI. So we should treat AI just like we treat humans. Okay. So the second camp says, no, but AI is more like software. Like, it lives in servers. You could have like massive numbers of them. Like AI, like, it's not gonna, like check their its phone for a second factor. It needs different authentication. So we should be treating AI similar to how we treat machines. That's the second camp. Okay. So then there is a third camp that says, no, AI is a completely different thing. We need to actually put AI on this kind of AI island. We need to isolate AI from everyone else. We need to have AI identity that's implemented in some interesting way. And then there is a fourth camp, and I will just spill the beans. I say, we belong in that fourth camp, that we say that fragmentation of identity in general is just a terrible idea. Even before AI, we should never treat humans and machines separately. In fact, we should have an identity implementation that treats laptops, servers, databases, microservices, AI, and humans exactly the same way. And here's why I think that actually is a winning strategy. First, let me kind of examine why other strategies will probably not work. If you look at how an agent behaves, you could, and if you want maybe to kind of dig deeper into what can happen from a cybersecurity perspective, Anthropic published a pretty wonderful a white paper, like a report of how malicious actors were using agentic AI to hack into companies. I think in November the report came out. You could Google it. So you could clearly see that it was an attack that was carried by automation, by AI agent that leveraged cloud code, but assisted by humans. And it was really interesting to see how the separation of duties worked. So AI, okay, the traditional microservice is really fast. It can do millions of servers, like millions of transactions per second. You could deploy it on millions of servers. So the traditional software is really, really, really fast, but it's really, really, really dumb. It can only do exact same action over and over and over again. So software is dumb but fast. Humans are slow. Like, we click buttons, we type commands on keyboards. Unless Musk and Neuralink improve us dramatically, so we're extremely slow, like glacially slow compared to software. But we're really, really smart, and we also non-deterministic. Like, what we do is really hard to predict. So that's the contrast: fast and dumb, and smart and slow. And therefore, these identity systems that we designed, they made us, like the designers of these systems, they made certain assumptions. So the identity systems designed for humans are designed for non-deterministically behaving smart actors who are slow and not that numerous.
Yeah.
And identity providers for machines, they design their systems for mass volume, for really, really fast actors who are relatively dumb and very predictable. But guess what? AI is both. It's really, really, really fast and also extremely deterministic, and it can actually be curious. So therefore, I'm making a case that no, you cannot use machine identity solutions for AI, and you cannot use human identity because they just don't fit that criteria. And furthermore, the argument against putting AI on an island is that you should never fragment identity in the first place ever, because by fragmenting identity, you're creating anonymity. So if you have a human identity or machine identity interacting with AI identity, and they're managed by two completely different systems, two completely different vendors, they become anonymous to each other. And that's really what enables impersonation, because attackers have no problems jumping identity boundaries. So for example, Red Hat recently got hacked because an attacker somehow got into source code of a microservice that some engineer was working on. They stole credential from that microservice, and then they became a microservice. So now you have a human pretending to be a machine. That's exactly why fragmenting identity is a really, really bad idea. And this is, again, what we're advocating, is that you should treat all of them the same. And the access control theory, the academia, is essentially on our side. So if you look at access control, for example, Wikipedia or anywhere else, you will see that it's all about subjects interacting with objects. Objects is easy. Objects is just data. But who's a subject? Everything and everybody. AI, machines, software, and humans, they're just all subjects. They should all be treated in exactly the same way. You also said something very, very interesting towards the end of the question, but I just don't want to be talking nonstop for 10 minutes. Maybe
No,
we'll
this is
talk
good.
about
This is
it later.
good. This is good insight.
It's the
Continue.
relationships part, remember? So when you mentioned that humans and machines and AI, they all need to, they don't exist in isolation for yet another reason, because they're related. So if you open a task manager, or on a Mac, I think it's called Activity Monitor, and you switch to hierarchical view, what do you think you're looking at? You're looking at a tree, how different identities in your machine are interacting with each other. So when your computer starts, there is a root process. That same root that we use in cybersecurity when we say root, right? So the root process starts, and then it starts launching, creating additional processes. They have identities as well, but they're now related. They have a parent. Each process on a computer has a parent process. So if you kill the parent, the child dies as well. And when humans are incorporated into that as well. So your operating system is treating you and Photoshop exactly the same way. When you're launching Photoshop, you go look at that tree, you will see that you launched Photoshop. So if you then kind of log off, or if you kill that user, the Photoshop process will be killed. The equivalent of that's what you need in your data center. So all of these microservices, all of these AI agents that you're running, they need to have a parent, because they're running for a reason. That reason has an owner, and that owner is a subject to policy. That owner has an identity, and it has certain privileges. So how do you manage that privilege transfer? The point I'm making, that these problems that we're trying to solve, they're not new. We've built most of the technology and the ideas that actually work, within the context of the operating system. We simply need to scale them up to a scale of a typical computing environment. So essentially, I would say the ideal, a very happy end state that we need everyone to be in eventually, if we really need to embrace AI and start taking advantages of it without being scared of it, is to build a tree. So these are all my identities in my data centers, starting with the root. And these identities, they have relationships. If a certain agent is running, it's because a certain human launched it and delegated some privileges. And why that human is there? Because that human also has a parent. So that is the end state. You need to have this kind of a tree of relationships between identities, all identities, not just human or non-human, are in one place.
There's so much to unpick there. I think this is absolutely spot on. I think we need to think of this as an end-to-end problem. I think absolutely, there are huge issues with fragmented human-centric identity, and then, as you say, you then multiply this with infrastructure, workload, and obviously now the agentic. So I think we absolutely need to think end-to-end. And the couple of things I jotted down there was, first of all, everything's in flux, which is sort of what you were saying around this sort of exponential adoption of hardware, software, the supply chain, and all of that stuff is constantly changing. Identity historically has been a very static focused way of doing stuff. You build a role model, and then you'll build your join and move a lever process, or you'd maybe issue some long-lived credentials for a SSH key or whatever it could be. It was static. It wasn't really expecting the business to change or the identity landscape to change. Now, clearly, that isn't the case. Everything is in flux, as Plato would say. But I think the other aspect, it is that unification. It is the carbon life form, the life cycle of the human, the life cycle of the infrastructure, the life cycle then of the agentic stuff. And I think you then have to have, as you said, the relations between those different identity types to allow the trusted execution to take place. And one last thing I want to add just before we dive into the framework is the bad guys, they don't care about your silos and compliance and your individual component stacks. They see an information flow. They don't care where the identity exists. They don't care whether it's an API key or a person or a privileged account. They want to go from here to there and execute on the object or steal the object or whatever it could be. They don't really care the path they take, and they will be more than happy to traverse multiple different identity types, which is
Yeah.
probably another podcast episode all on its own. But is this fixable? Can we do something about it? You guys have brought out this the teleport agentic identity framework, which I've brought up on the screen there. And this is a very big, broad, end-to-end way of thinking about this problem. And I'm pretty impressed with it. There's lots of different aspects to this. We're not just looking at things in isolation. We are looking at the agents. We're also looking at the MCP angle and how that's interacting with the downstream data angles as well. And obviously, that itself is going to be sitting on, hopefully, a secured infrastructure as well. So I guess you see the market is missing something like this.
Mm-hmm. I would even say that, like, before we even begin talking about the framework, because framework, like the way it's designed and documented, so we presented it, first and foremost, it was designed and presented to our users, people who are already familiar with Teleport and with our view on the world. Maybe I could spend a couple of minutes kind of getting your audience up to speed. So the most important thing that we want people to understand is that you need to bring identity into your infrastructure stack, okay? Because historically, most organizations, they would have their infrastructure over here and their identity over there. So identity of your humans in your organization are like in Okta, for example, and here's your infrastructure here in data center. And by default, infrastructure doesn't have an identity, it's basically naked. So here's what I mean by that. Compare your data center to your Apple devices, like in your home. You can go to your Apple account, and then you click on My Devices, and you'll see your laptop, you will see your MacBook, your iPhone, your iPad, your EarPods, all in one place. You didn't add them there. Why are they there? Like, how does Apple know that you own all of these things? And then suddenly they recognize themselves and they treat each other with respect and trust. You can copy paste from a laptop into a phone. Somehow you can like transfer files using AirDrop, and you're not seeing any login screens somehow. So that is because Apple built a trusted hardware layer into everything they do. Do you have it for your infrastructure? That's the layer. That's the identity layer. Every server in your environments needs to have a strongly implemented identity, because servers are not created equal. Some servers are staging. There's some servers used for testing, others for production. Some servers have data, other servers don't have data. Some servers are subject to FedRAMP level high, other servers are subject to PCI, some other compliance regime. So you start by issuing strong identity to servers. Then you need to start to do the same thing with software. You need to issue identities to everything that you run on your machines. You need to have identity for your database that runs in a Kubernetes cluster. So you need identity for that cluster. You need identity for every microservice. And all of these identities need to be implemented in the same layer. So that is a prerequisite for you to make your infrastructure safe. For AI adoption, first you need to bring it into this trusted state where there is no anonymity and your identity is not fragmented anymore. Now you can bring non-deterministic actors like humans and AI agents, because now everything they will try to touch, you already know what that is. You cannot secure what you don't know what you have. So you have to get rid of anonymity first. That is a prerequisite before we even begin talking about agentic, like a identity framework. So you need to have an identity layer in your infrastructure that covers everything you have.
One thing I'll add in there, I think once you have that, then that becomes, it's almost like a secure running state, isn't it? I think that's something again where in the sort of world of constant change and constant flux, you want to start off. You mentioned sort of hardware process attestation and sort of the boot up angle, and you want to get to a position where you have a level of security and trust, and then you can whatever deploy
Yep, yep,
downstream
yep.
applications and stuff. It's almost you want to get to that point first, and you get to that secure running state, and only at that point you can then start to do the stuff which is
Yes,
adding
yes. So
value.
if
Or
you're not at that point, you're not even ready to talk about agentic identity. Like you really, really need to start earlier. And look, people will rightly push back on this. It's like, look, man, it's a lot of work. Look, we have so much like gear, we have legacy systems, we have multiple generations of technology layered on top of each other. That's normalcy. That's what everyone is facing. And frankly, look, obviously I will be self-serving by saying this. That's the problem that Teleport truly solves. That we make this complicated, messy, and seemingly insurmountable problem go away. So it is easy to enroll your infrastructure into this trusted state, to issue identities to everything and everyone in your environments. That's really what we've been selling for the last few years. So once you are in that state, now we can have this debate and conversation about how to bring AI into that kind of trusted environment that doesn't have anonymity anymore. And that is where this agentic identity framework that we're suggesting comes into play. And by the way, I want to highlight something here. This is not an advertisement for Teleport. The framework actually suggests like components and technologies for infra that doesn't have anything to do with us. It's like industry best practices, how to contain AI workloads in production in 2025, 2026, based on what we've seen in the real world.
I think it's that's great. I think this. I think the isolation thing is definitely a problem, and it has to be geared and positioned around that underlying set of components. It isn't just running in isolation. I think the angle really around the infrastructure is that many organisations that they aren't running secure and trusted infrastructure. So again, back to the sort of hosepipe angle, you may well secure certain parts of your AI world, but ultimately, if you're built on weak foundations, a lot of that becomes irrelevant because, again, the adversary is going to find the weakest link in
Yeah,
that
very,
security
very easy. I
ecosystem.
could give you an example. Sorry, I feel like I interrupted, but I could just. Sorry, I just got excited in the moment.
Oh, you go ahead, go ahead.
Here's a very typical example. Actually, happens with some regularity, like how deploying AI on top of weak infrastructure will make you vulnerable. So, okay, so you have your AI agent running in the infrastructure and it's doing all these wonderful things, and you feel good about it because you applied like solid policy on your agent, and your agent can only do like certain things, and you maybe created some network isolation around. I don't know, like you using all kinds of tools, so you feel happy about it. But I can come in and can pretend to be a database. I can trick your agent to come in and write data to me. I will take the data, run away. I will mess with your DNS. I will reroute API requests that agent is issuing, and I will just go and be a database. Kind of goes back to the earlier example of how hacker pretended to be a microservice, pretended to be a piece of software on the other end of an API gateway. So the point is, like, that's what identity fragmentation does to you. You might be deploying an agent into an environment that already has some malicious actors in it. So therefore, solving an identity problem in isolation, like identity problem for agents or identity problem for humans or identity problems for microservices, it's not going to help you. You need to have an identity story that covers your entire environment, just like it does in the case of an operating system.
100%. And I think actually, ironically, if you do have that strong foundation, some of those later secondary controls actually become slightly less relevant because you're starting off with a secure
Yeah.
foundation. It ends up being slightly a bit of an overkill ultimately. But I guess there's a few things which sort of stood out to me looking at the framework. I think one, it is agnostic really, and it is looking at the bigger picture of how you can secure this ecosystem. But it's nicely broken down into various different angles. You talk about the agentic identity, first of all, which is very important. What does that look like? How do you,
Yeah.
because in the human world, we have an HR system, and we sort of define the employee as an identity, and you then maybe give that some sort of credentialing strong auth stuff or whatever later on. But we need to define what the agentic identity is and what that looks like before we can even talk about just-in-time
Absolutely.
permissions and authorization. So is that a simple thing?
Yeah. Oh, well, yeah, like the answer is always it depends. So, like when it comes to agentic identity, so the most important thing, which is what I started with, is it needs to be implemented exactly the same way as you implement identity for anything else in your environment. That is because, again, identity fragmentation creates opportunity for impersonation. You don't want that. So now, how is that implementation actually looking? So there are kind of two things to talk about here. One is like what is the process of an agent issuing an identity? Like how does it actually happen? And we break it down to 3 use cases. We not telling you which one to pick, that depends on your use case, but roughly there are, like what we're seeing is that the 3 common methods that the organization use. First is you essentially treating your non-deterministic microservice, which is what AI agent in this case is, exactly the same way as you treat any other microservice. So you issue a credential to it, so it becomes like, let's just say that it's like in the form of a digital certificate, which is derived from like hardware security module on a motherboard on some server or something like this. So now you have an agent that is basically treated exactly the same, like the way how software historically been treated. So that is one approach. Second approach is it's very similar to this one, but think about the durable identity idea. So the idea here is that you have a microservice that you keep deploying, redeploying, you keep modifying, but you want that thing to have exact same identity for years and years and years. Maybe it's important for, like compliance, audit purposes, whatever. So this is kind of the idea of a durable identity. And the third use case, sometimes people call it digital twins. So this is when you're creating an agent on the fly because a certain human demands that agent to exist. Like you have a task that you want to perform. Maybe you click a button somewhere, or maybe you automate it via scripting. So you're creating an agent, and then you letting that agent borrow some of your credentials and go execute a certain task on your behalf. So that agent becomes kind of your child. Like when we were talking about these trees of processes and operating systems, it's kind of similar concept to that. And there is a complication there as well, because you might have it on the client. So you might have an agent running on a desktop, on a laptop, or you could have it in the data center where you click a button and the agent microservice gets instantiated somewhere on AWS. So those are things that we are articulating in a framework and providing you with recommendation. But again, what's important is that the issuer of identity needs to be exactly the same as the issuer of any other identity in a company. Because even when you define policy, like what is a policy? Policy is a statement. Like in that statement, you want to be able to refer to identities of different types. You could say, this agent is allowed to read data from this table, from the database, only when a person with a particular attribute in an organization using a particular laptop on a particular network segment asks a particular question. So notice how many different identity types I referred to when I articulated this policy. So, and if you manage these different identity types using different systems, the good luck trying to enforce something like this. So that is the most important thing.
Yeah.
And the second comment that I want to zoom into regarding implementation of that identity for everybody, not just AI agents, is that the identity implementation needs to not rely on static credentials.
Mm-hmm. Mm-hmm.
So we talked about the importance of static credentials that, like essentially, like at some point they become impossible to manage. They're going to leak. You can vault them, you can encrypt them, you can rotate them, but eventually they're going to leak. Like as complexity goes up, they will leak. So you have to use authentication methods that are connected to physical world principles. So if you have like a certificate that is really, really short-lived, just like a certificate to complete a certain operation, and the certificate is issued using a certificate authority that's baked in hardware, like on HSM somewhere, that is a method of authentication that you don't have to worry about leaking. And you have to do it for machines, and you have to do it for microservices, and for humans, for AI, for everybody, because then your exposure footprint will always be zero. Your exposure to credential leaking will be zero, simply because you have no credentials that can be leaked. That is really, really important at scale.
I think that's fascinating, isn't it? I think over time, you think about risk management. We spent a lot of time sort of trying to mitigate and reduce certain problems within the identity world, but actually sometimes just remove the problem entirely. And I guess passwordless is trying to do that with passwords in the human space, because the password problem was just never fixable. So we sort of tried to fix it, and we could never reduce the risk to a certain level. And I think back to your point there, I think just remove the problem entirely. Ephemerality for credentialing, the sort of standing zero problem and secret zero problem of getting to be able to issue some sort of cryptographic credential, just in time permissioning, zero standing. You sort of remove the problems entirely, because even if
Yes,
the
there
problem
should be
is,
no. That's right. Like, I do want to critique some passwordless implementations. There are some vendors and even open source projects out there that say like, "Hey, we have this passwordless thing, so you could just do biometrics and whatever." But password is not. It's a very narrow definition of a problem. Like I would encourage you to think of secrets. So many different systems, they essentially convert your fingerprint to a browser cookie, and then if I steal the cookie, then I become you. So what's the point then? So how's cookie better than a password? No, it's not. It's the exact same thing. Or like some people would say, like, well, a public-private key pair is way better than a password. And like, why? Like, private key is just a password, just very, very long password. So the problem remains that you have data that if that data leaks, someone will become you. Like, think about it using generic terms like that. So therefore, you cannot rely on data to implement identity. It's as simple as that. Your identity implementation should not rely on some ones and zeros existing in some place, because they will leak and you will get owned. So your identity implementation needs to be kind of hard connected to physical world principles, hardware security modules, trusted platform modules, and biometrics. So that is identity implementation that cannot be uploaded to some server somewhere on the dark web.
no, 100%, 100%. I mean, it's again passwordless. That's probably another episode on its own. But I think it is back to first principles, and I think that the framework really is looking to just amplify, I guess, two things. One is the concepts, as we've been describing, the first principles of successful identity for humans, and taking some of those constructs and applying them in a different setting, the verification, the credentialing, ephemerality of aspects, but I think also how to do that. And scrolling down through here, again, lots of nice integration points here. It isn't just, it takes a village, I guess, to secure this agentic world. And absolutely, there's infrastructure. Yes, there's going to be data in there as well, and the access angle. But obviously, even though this is a relatively new framework, there's already integrations and how to do this stuff against other infrastructure components, whatever SSH databases and Snowflake. And so I think it's vitally important, isn't it? It is going to touch every single part of both your infrastructure and sort of data world. So I think that to me is quite an important aspect, that this does seem to be more about the concepts, more agnostic, in applying some of these concepts into a broader
Absolutely, absolutely.
ecosystem.
So we even recommend things that seemingly have nothing to do with security, but we believe they're essential if you want to deploy AI in production successfully. So as I said earlier, like even prior to considering AI, you need to bring your infrastructure into this trusted state by issuing identities to everything you have. But in order for all of these resources to become useful to AI, you need to expose them through MCP. So we have some recommendations on how to run and manage a bunch of MCP servers in your infrastructure now. Because essentially MCP is a translation layer between infrastructure and the things that AI can actually do. And so the way how you roll out your constellation of MCP resources, how you manage their visibility, how to manage privileges there. So we have some recommendations about that as well.
Great. I think it's great. I think it's thinking strategically, which I think may have been lacking maybe 12, 18 months ago from the entire industry around the sort of AI security ecosystem. So this is really, really nice to see. And I guess sort of wrapping this up now, I guess what's next? What's next for the framework, and how do you see that developing and growing? I guess this calendar year. Where do you see success with this maybe a year from now?
So you essentially asking me to predict the future, because
Absolutely.
when like our position is inherently reactionary because we need to embrace all of the innovations that are coming out of leading AI labs, right? So, like, we didn't have MCP, and then Anthropic gave us MCP. And then we all, like, as an industry, we had to respond and we develop industry best practices to do it. And my prediction, it's just not going to stop anytime soon. AI is just frankly too new and it's advancing at a rapid pace. I expect additional capabilities to be launched and released, not just by Anthropic, but OpenAI and like other players, maybe like Google or NVIDIA. So we need to be constantly on the lookout how like what are the best practices are going to emerge to deal with these new developments and how we're going to incorporate them into the framework. Like the most recent one was, for example, skills when they released that capability. So like a bunch of people now wondering like, where should I use skills? Where should I use MCP? So which means that we need to be updating the framework with these new capabilities as they become available. But also, so that's on one end that we need to respond to what AI labs are introducing to the market. And then on the back end of it, as people begin to use these principles in production more and more frequently, they will discover use cases. Some of them would be edge use cases that you probably that will be hard to generalize. But some blind spots will probably be discovered, and the feedback will be received, and we will have to go and be updating framework with that additional insight as well.
Mm-hmm. I think you've hit the nail on the head. I think change is the huge angle to AI in general. It's in flux, which it should be, and I think there's multiple aspects to that. Whether it's the external threat side, as you say, the innovation on the AI lab side, and how fast that's going to come to market, and then obviously there's operational maturity as well, and how the AI components can be consumed within the enterprise. I think that is still in flux as well. So there's multiple angles to keep happy.
Yeah. There is also one angle that technologists don't talk about much. I don't know why. It's actually, I think it's fascinating. Um, it's the importance of human systems. It's the importance of things like org chart. Like if you look at your like engineering or your IT organization or any other organization and look at the org chart, you have these teams and sub teams. Like what dictates that they look this way? And you quite frequently realize that the org chart reflects the status of technology. If you look at, for example, like IT team within an organization, you zoom in and there is a network team there. Why is that team a team? Because networks were invented. Like back in the day, we didn't have networking, we didn't have the team. Now we do. So, and it's a very interesting cross-pollination how technology influences org chart, like I just described, but it can go the opposite direction as well. Because if your org chart, for example, fragments identity, so if you have like a title, like VP of human identity, I'm exaggerating, of course, but VP of human identity, and that person has a job and compensation and incentives behind it. So they're not going to even bother about AI identity or machine identity because their title and job and scope of their responsibilities is just on humans. So I expect businesses, corporations, organizations, government agencies to start rethinking these things because they will have to be rethought. Or like here's another example, like where we have this concept in cybersecurity centered around anomalous behavior. Like, oh, anomalous behavior. This behavior is anomalous and this one is not. Like what dictates what constitutes anomalous? Like, well, it's because of something like it didn't do before. It's a behavior that's new. But then I would ask you the question, why do we believe that AI is going to be so valuable and it's going to produce so much more innovation and productivity? And the answer to that question, because AI can bring us additional insights. AI can do more than just a dumb deterministic microservice. And I would say, but isn't that also anomalous activity? Like how? Like think like we want AI to be creative. We want AI to be curious. We want AI to suggest us things, and then at the same time, that's not anomalous activity somehow. So we need to reconcile these conflicts even in our own heads before we then start designing frameworks, best practices, APIs, and designing products. Just generally saying, there's going to be a lot of change in the industry, not just contained to technology.
That's a really good place to end. I guess you're probably not then a proponent of having a chief AI officer. Do you think that's going to be a thing of the future, or does that just break and create more fragments? I think it.
I did offer to add an AI board member here at Teleport.
Okay. Okay,
and it
okay.
was received semi seriously. But some people did scratch their heads, so I think there is something about it.
Well, it's definitely the rise of digital employees, obviously based on this concept. But I think back to the fragmentation angle and the structural angle. I think the more we move and talk about information flows and things being end to end, it creates much more fluidity, much more ability to respond to change. And I think change is all around; it doesn't stop, and it's often external to both the tech and the organisation. So the more fluid an organisation is, like the tides, it can respond to whatever, whether it's AI or the tech or whatever it can be. Absolutely fantastic conversation and chat there to understand a little bit more about the sort of vision behind this. I think ultimately this is definitely a hugely powerful and important contribution to the industry. But I think as well, it'd be amazing to maybe sit down February 2027 and just to see how much change takes place over the next 12 months with
Yeah.
respect to AI. I think it'll we second guessing ourselves for a long time to come. But thank you for sitting down with me and explaining some of the background behind this. I think it's a fascinating concept and project. It's end to end, it's broad, it's agnostic. I think it's all the things we need in the identity world. Ev from Teleport, thank you for sitting down with me and taking a little bit of time out. Thank you to the audience for watching, and we will see you next time. Thank you.